The shape of a decorative vase is modelled by revolving the curve AB, which we can see in the diagram below, about the y-axis where x is equal to y squared minus 11y plus 35. It's the square root of all of that, with y being between 0 and 7. All dimensions are in centimetres. Determine an integral expression in terms of h for the volume of water in the vase if it is filled to a depth of h centimetres. So we're revolving around the y-axis. So the volume is going to be pi x squared dy. So v is going to be pi times the integral from 0 to h of x squared, which means we just get rid of the square root on this. So it's going to be y squared minus 11y plus 35 dy. And that should suffice for part A. Water is poured into the initially empty vase at a constant rate of 50 cubic centimetres per second. Determine the time taken to fill the vase to a depth of 6 centimetres. So in this above integral, we're talking about h being equal to 6. So we can just do that integral on the calculator. So this time I will grab the calculator and we'll just do it. We'll go to our main screen. Let's just clear anything that's there. And we know that the integrals are in Math 2. So let's grab the integral here. Let's go 0 to 6. And it's going to be y, open bracket, y squared minus 11y plus 35, close the bracket, and that is going to be with respect to y, and that gives me 162, but of course I didn't multiply it by the pi in front, so I'm now going to multiply that by the pi, and if I did that in decimal it would be better. And so that is 508.938 and so on. So volume is 508.938 and so on. And so if we want the time, it's just going to be that volume divided by the rate, which is 50. And we can calculate that. It comes to 10.1787. Which I'll just round to 10.18, and that will be in seconds. With the depth at 6 centimetres, another 30 centimetres cubed of water is added to the vase. Using the increments formula, calculate the approximate change in the depth of water in the vase. So delta H is going to be dH dV delta V. Now, dV dH, so we know that V was this, so dV dH, just use the fundamental theorem of calculus, and we can see that it's just going to be this with h's in, and we can expand that out. So dV dH is pi into h cubed minus 11h squared plus 35h. And that means that delta h is, dH dV is just going to be 1 over that. And it's going to have the 6 substituted in. Like so. And then we need to multiply it by delta V, which we were told was 30. So just up here. And calculate, and it's 0.3183 and so on, and so approximately that is 0.32 centimetres if we just go to 2 decimal places.